Physics students, I am Phy.PVI, Department of Physics, New Arts, Commerce, Science College, Shevgaon, District Ahmednagar. TYBsc Physics Semester 4th, Chapter 4, Laser Output. Topic is a Doppler broadening. But before going to study the Doppler broadening, we just review the previous broadening mechanism, that is the collision broadening, or it is called pressure broadening. And the broadening emission and absorption lines is called as the collision broadening. Okay, and the magnitude of these effect depends upon the frequency, and that is the mu collision at which such collision occurs, and thus a frequency can be calculated as mu collision is equal to mu threshold eta sigma collision. And suppose that this equation has a 1 here, and we know here these eta is a density of the atom, it is a density of atoms, and these sigma collision, which is the cross-sectional area of the collision, that is the cross-sectional area of collisions. Okay, and here this new threshold is the speed of the atoms. So here this the broadening, that is the collision broadening, that is if the atom which is emitting a wave train undergoes collision, then the phase of the wave train is suddenly changed. An effect produce shortening in the wave train is known as the collision broadening, or it is also called as the spectral line broadening mechanism. And here these collision broadening results from atomic or the molecular collision in a gas or in a solid. So collision broadening is homogeneous, and collision causes random phase jumps in the wave function. Okay, so therefore thus these broadening of the emission and absorption lines is called as the collision broadening. Okay, so here after a revision of these collision broadening, here we just turn towards the Doppler broadening. So this Doppler broadening, which is the inhomogeneous broadening. So Doppler broadening result from the difference in frequencies these measured for the radiation emitted from atoms as they travel away from or towards an observer. So here these broadening, this collision broadening, which is an example of the inhomogeneous broadening. It is the inhomogeneous broadening collision. And a Doppler broadening is the broadening of the spectral lines due to the Doppler effect caused by distribution of the velocities of the atoms. And here these different velocities of these emitting particles result in a different Doppler shift. Okay, so the frequency measured here by observer increases by these source and observer approach each other, and decreases when they recede. Okay, so in a gas atom can move randomly, therefore observer can measure a range of frequencies, and this broadening of the line is called as the Doppler broadening. So this broadening occurs under Doppler shift, and so therefore the line shape function, the line shape function, of this broadening, which is given as g nu 0 is equal to 1 upon delta nu, and here this is the equation number 1. And here if nu 0 is the centroid frequency, it is the centroid frequency, it is called as a centroid frequency, and here of this absorption line, then the Doppler effect will shift, and then the frequency towards spectral lines broadened. So therefore nu is equal to, here nu 0 1 plus Vr upon C, so that is equation number 2, and nu is equal to nu 0 plus nu 0 Vr upon C into the 3. This is the equation number 3. Okay, this is equation number 3. So nu is equal to nu 0 1 plus Vr upon C, and nu is equal to nu 0 plus nu 0 Vr upon the C, to equation number 2 and 3. And here this Vr is the component of the velocity, this is the component of the velocity, and so therefore of the absorbing atom along the line of the side, and thus the Doppler shift, this Doppler shift has an amplitude, and this amplitude here nu minus nu 0 is equal to nu 0 Vr upon C. Nu minus nu 0 is equal to nu 0 Vr upon the C, and therefore this shift delta nu is equal to, here nu 0 Vr upon the C, and here this is the equation number 4, and this is the equation number 5. So it is called as the equation 5. Delta nu is equal to nu 0 Vr upon the C, equation number 5. So here this is the Doppler shift, and this mechanism, it is nothing but the Doppler mechanism. Okay, that is the Doppler broadening is the broadening of the spectral lines due to the Doppler effect caused by the distribution of the velocities of the atoms. Okay, so these are Doppler broadening, which is the example, of the inhomogeneous broadening mechanism. Okay, so we stop here, and in the next video lecture we will see the full width at the half maximum and the gain medium. Okay, so thank you all of you.